Welcome to July 22nd's LeetCode challenge. Partition array into disjoint intervals. Given array nums, partition it into two contiguous subarrays left and right so that every element in left is less than or equal to every element in right. Left and right are non-empty. Left has the smallest possible size. Return a length of left after such a partitioning. It is guaranteed that such a partitioning exists. Okay, let's go. We have array nums here, and we have these set of numbers. And then if we were to partition it into two left and right, we know that, let's say, for instance, 5 plus 0 plus 3 equals 8, and 8 plus 6 is equal to 14. So therefore, there's 8 on the left side, and then on the right side, there's 14. The reason why it's partitioned to 3 and then 2 elements here is because 8 is less than or equal to the right, because the next element after that would be 6, and it has to be contiguous. Likewise, we have this array nums here, and we take in the array, the subarray 1, 1, 1, 0, which makes the sum of all the left array equal to 3, and then we move on to the next element, which is 6, and then 12, which makes 18. So 3 for left versus 18 sum for right. Return output for left is 4 because it has its 4 elements, and while right has 2. And because 4 is less than 6, which is the next element in this index right here. So that's pretty much the general rule of the game there. Num's length is between 2 to 30,000. Num's index is between 0 to 10 to the 6. Guaranteed that at least one partition num as described, so that it exists. Alright. How do we go about doing this? So we could build a left max array so far and a right max array so far, and then continue going down using a for loop. That is one way of doing it. Another way is probably one of the ways that I kind of always like to do things is as a one pass type of solution. So basically, I'm going to go through, iterate through the array, and then I'm going to keep the max currently. So take the sum of all the index as I traverse down, as I iterate through the array nums, and then I'm going to look at the max. So if the sum of the array as I'm iterating down ever becomes larger than the next integer, or the sum so far, then I'm just going to return the partition number plus 1. Alright, that's how I'm going to do that. So I'm going to call this function left, and it's going to be the max. I'm going to call it left, which is going to be the left array, and then I'm going to assign another variable called global. So this is going to keep track of the global. Oh, can't do that. Call that let's see. Overall, no. Call it max either. Global max. There you go. It's going to be nums at index 0. So basically, we're going to keep track of the left array, subarray, and then we're going to keep track of something we're going to create something called the global max array as well, subarray, and it's going to start off at nums at index 0, which is the first number. So it's always guaranteed that the array itself is always existing, and that they're non-empty. So we'll take the first element to be the left. And then we're going to have partition equal to 1, because we already have one element inside. Alright, so what we're going to do is do a for loop here, and let's actually going to call this 0, and we're going to add 1 at the bottom. So for element I, index I, in range 1 to the length of nums, what we're going to do is iterate through each of the each index, and we're going to keep track of our maximum value, which is global max. So which is going to be the max between global max and nums at index I. Alright. So what we're going to do is basically, yeah, it'll continue and we'll see how it goes. Alright, so we'll have that variable which takes in the max variable and the nums and the max number at index I as well. And then if the nums at index I is greater and less than left. Give me 1 second. Actually, this should be, yeah, less than left. So if the nums at index I is less than left, maximum number I should say, then num sub index I belongs to the left array. So therefore we could repartition it and make it as part of the sub left array. So we're gonna increase partition is gonna be equal to I. Assigned to I, which is the number in what that we're iterating the index number that we're iterating through the array. So we're gonna update that. So it means that it's part of left the number nums index I is part of the left array, and then we're gonna make the left array to be assigned to global max. And then that's pretty much it. We return partition number plus 1. Alright, let's see how this goes. Oh, got an error and for I in range. Let's see. Nums at index 0, partition equals 0 for I in range. Take the max of and nums I less than max. Partition I left. This should be out here. Let's see. Submit. Accepted. Awesome. So time complexity would be big O of n, because we're iterating through each index in the length of nums. So where n is the length of nums, I should say, which is less than or equal to 30,000. Space complexity is big O of constant space, because we're only keeping track of a single variable here, which is partition, and then we're just incrementing each time with assigning to I each time, and then we just add 1 afterwards when we return it. So yeah, this is a nice and concise solution here. I kind of enjoy it. It's called it's a one-pass type of approach. As we keep track of our basically our numbers, adding it along, finding the max as we iterate through our array. All right, that's it. Have a nice day, guys.